Welcome to the design of concrete structure class. So in the last two classes we have discussed about the basic design philosophies of concrete and structural design, and in the last class we have discussed about the loads. What are the different loads acting on a structure? Either it may be dead load, live load, earthquake load, snow load. All these loads we have discussed in details in the last lecture. And then at the lastly we have discussed about the load combinations also, like all the loads will be not acting in a structure together, so we have to make some combinations as per our Indian standard code, and we have to finalize the loads coming on a structure. So now in this course we are more concerned about the concrete structure, design of concrete structure. So concrete is a heterogeneous material. So before going into the actual design of concrete structures, let's understand the properties of concrete structure. Because once we don't know the actual property behavior of concrete with the different loading conditions, we actually cannot construct a structure. So that's why each properties of concrete has to be investigated correctly. So it is essential that each designer has to acquire a fair knowledge of the material to be used in the design of reinforced concrete structure. So basically this lecture will be summarizing the different characteristics properties of concrete, and in the next lecture we'll be discussing about the steels, because in reinforced concrete structure primarily two types of materials are used. One is concrete, another is steel. So in this lecture we'll be discussing about the concrete properties, and in the next lecture 4 we'll be discussing about the different properties of steel. So now let's get started. So what is concrete? So as we know everyone that concrete is a mixture of coarse aggregate, fine aggregate, cement and water. So these are the basic four ingredients which if you mix properly then concretes are made. So the coarse aggregate we call it, this is nothing but a gravel or aggregate, big aggregates we use, and this fine aggregate is nothing but a sand we use. And the different grades of cements are also available, so we use cement, and then water is also added into the mixture, and ultimately concretes are made. So now you can see that the concrete is not a single material, it is a mixture of 3-4 different types of materials. So that's why the properties of concrete also will vary with the different grades of materials which is used for the making of concrete. So the properties of each material also has to be understood thoroughly to understand the overall behavior of concrete. So you have a course that building materials, construction materials and practices. In that course you will be studying more in details about the concrete properties, how concrete has been made and what are the individual properties of each material. But in this course we'll be I will just summarize all the properties and we'll go further and we'll design our structures. So the properties of concrete, that is its either its strength or its deformation, depends on the individual properties, that is cement, sand and aggregate and the water, and sometimes we mix some admixture also into the concrete to make the concrete more workable. So all these properties are actually given in our Indian standard 456 2000. In that 456 2000 clause number 5 and 6, the standard procedure for making the concretes and all are mentioned in details. So now once concretes are prepared, so here is a side picture. You can see beam, column, slab, joints. So this is a typical slab, and these columns are coming from the bottom foundation, it goes up, and these are the beam column joint. So very important beam column joint it is. So you can see how the reinforcements are placed, and now concrete will be poured in the gap, and ultimately our slab will be ready. Similarly, you can see this is a column, skeleton structure of a column. So now this column will be casted. So you can see how the reinforcements are binded together, and these horizontal things are actually called tie. Okay, so basically it is tying up all the 4 5 reinforcement longitudinal bars. So these are the few site photos. Now these are more site photos. So once you saw the skeleton structure of a building, now we make the shutterings before concreting. So these type of shutterings are made in a real structure, and above that we pour our concrete. So once we pour the concrete, the curing of concrete is required for next 28 days. So we will spray the water, or sometimes the wet cloths are placed on a concrete to make the curing part taken care. because during the curing part only concrete gains the strength. So these two are also very much important. So how the shutterings are made, it is shown here in real site. Anywhere if you go, you will find this type of shutterings are done. Either it may be made up of wood structure or it may be of steel, whatever it may be. But shutterings are made primarily to pour the concretes, and then curing is done for the next 28 days or so. So now, before going into the exact properties of concrete, so we have to understand that concrete, we are discussing about the reinforced concrete. So reinforced concrete is actually made up of two material, right? One is concrete itself. We saw how the concrete is made. Concrete is made up of coarse aggregate, fine aggregate, cement, and sand. These four materials we made concrete. And also steels also required at the middle. If you saw the last picture I have shown, the skeleton structure of a column, here you can see 4 or 5 reinforcing bars are also placed. Then only concretes are poured. So basically here we are using concrete and steel, two materials. Why we are using concrete and steel? Why steel is required then? We can make the entire structure using concrete itself, right? But there is a limitation in the concrete. Concrete is very good in taking the compression force. So as long as you apply the compression force in a structure, either if it is made up of concrete, then concrete can take the compressing strength before failure. Whereas concrete is very weak in the tension. So in a structure, some parts will be subjected to compressive force, some part of the structures will be subjected to tension. So concrete is very good. He can take very good in compression. So anywhere the compression forces are acting, there we will provide the concrete. Whereas in some portion of the structure, only tension force will be applying. So in that location, we'll be keeping the steel reinforcing parts to taken care by the tension force, because concrete is very weak in tension, whereas concrete is very strong in compression. So these are the different properties of concrete, which is we'll study in this course and which will be required. So the first properties of concrete is characteristic strength of property, characteristic property. Next one is flexural strength property. Next is elastic deformation of concrete, shrinkage of concrete, creep of concrete, and thermal expansion of the concrete. So in this course, in this lecture, basically, I'll quickly go through all the properties of concrete and we'll try to identify what our Indian code says about each properties of concrete. So now let's get started with first property, that is the concrete strength property. So now this is the concrete strength property. So how the concrete strength is measured? So whenever we construct a structure, basically it is either made up of concrete, right? Concrete and steel bars. So concrete, again we saw, is made up of three different intermediate materials. One is coarse aggregate, fine aggregate, there is sand, cement, and aggregate and water. So these four things, if you mix together, you will get the concrete. So now these four things can be added in different manner also. So in sometimes you can add more cement to the concrete. Sometimes you may add more coarse aggregate into the into the concrete. So depending upon these 3 4 ingredients, if you mix in different proportions, you will get different grades of concrete. Some concrete will be very strong, where you use more cement content. If you give less cement content, then the strength of the concrete will be less. So depending on this proportion of these 3 or 4 ingredients, the different strength of concrete will be achieved. So now the question is, now for example, you have made a concrete. So normally we denote in reality let me just write it out here. So we denote concrete strength by M. M, then maybe 20. Next time if you go to any site, you can see that engineers will be telling this concrete is made up of M20 or maybe M30. So like that nomenclature they will give concrete strength, or maybe M40. So these are the basically different grades of concrete. What is M? M is basically mix, and 20 is the compressive strength, characteristics compressive strength of that concrete, 20 MPa. So this means, so this is 20 MPa. So MPa is nothing but Newton per mm square. So this grade of concrete has a compressive strength of 20 Newton per mm square. Similarly, this grade of concrete has 30 Newton per mm square MPa compressive strength, characteristics compressive strength. Okay. Now, as I mentioned, that concrete is actually made up of 3 4 different types of materials. One is coarse aggregate, fine aggregate, sand, cement. Correct. Now these materials will be mixed in a site, and which so many uncertainties will be there in the strength, because the aggregates are also collected from the nature. We break the hills and we collect the stones. Similarly, sand also will be collected in the riverbed or somewhere. So these materials will have lot of impurities with it. Coarse aggregate also will have impurities, sand also will have impurities, right? Even the water which is added into the concrete for mixture, that water also may not be pure, it may have some impurity. So in each material which is making the concrete has an impurity. So this impurity will lead to the variation in the strength of each concrete. For example, these concrete cubes, you can see these are the cubes. This concrete is made up for M20. Okay, so M20 means the compressive strength of this aggregate, these cubes should be 20 Newton per mm square. But what will happen? As I mentioned, that concrete is made up of different types of materials, and each material has a impurity in. So the strength of the all cubes may not be same, although the design is made to make concrete cube M20, that is 20 Newton per mm square is the compressive strength. But if you test all the cubes in a site, so this is a compressive test strength testing machine. So all the cubes are placed here, and basically we can measure what is the compressive strength of each cube. So once you perform this experiment, you will find that all the concrete cube has different strength. Although all concretes are made for 20 mm, so this compressive strength should be 20 mm. But if you perform experiments in reality, you will find each cube will have different strengths. Some will have 21, some will have 22, some will have 18, some will have 19. So all concrete cubes will have a different value. Why with different value? Because the material used in this concrete, in these cubes, are actually has impurities, very highly impure, like that sand, cement, aggregate, all these things will have impurity. So these impurities actually causes variation in the strength of each cube. Although all the cubes has been designed for M20, but each cube will give different values in the compressive strength. So now the question is, in the design, now when you design a structure, which value will you take? So in reality, although the material is concrete is made up of M20, but each cube, if you perform experiments, you will find different values. One will have 20, maybe. So total 100 samples you made. So you made total, for example, this is just a demonstration purpose. So total 100 cubes, this type of cubes you have made, total 100. And all hundreds you have performed the experiment here. In this experiment, you performed all 100 cubes, complete strength you are finding out. So what you will find? So once you do the experiment, you will find something like 55 samples will give you 20 MPa. So this is just a demonstration purpose. I am giving some number, but in reality, this number may vary. So out of 100, 55 sample will give you the 20, which is designed M20. So maybe 30 samples or maybe 20 samples will, or not 20, maybe 10 sample will give you 21. 10 sample will give you 22 compressive strength I am talking about. 10 sample may give you 19. 10 sample may give you 18 MPa, right? So now maybe again 2 sample may give you 17, and 3 sample may give you 23. So total if you count, it will be 100 now. Okay, so this is just a demonstration purpose. I have given some random values, but in reality, if you perform 100 strength, you will find that all 100 won't give you 20. Although it is designed for 20, it won't give you 20. It will give some different values. So once we get all these values like that, so once you perform the experiment, you will find different values. So now we can plot a histogram with these values. So this is a histogram, means maximum. See, maximum you will get 40. So here this histogram is made up of for 40 MPa. Anyway, here we have 20. So maximum sample out of 100, 55 sample will have mean value, middle value. Few sample will give you more value, like 10 sample will give you 21, 22, something like that, and 10 sample will give you 19, 18, less value also with the mean. So using this step values, we plot this type of histogram. So once we plot the histogram, in histogram we can see middle means mean value. Mean value will give you maximum. So here it is 40 MPa. So this plot was made up using the M40 concrete. So that's why mean value, if you see, it is no 40. Maximum values are 40. So now, so this is a histogram of a compressive strength. Now the question is which value will take. So concrete strength is actually varying. It is starting from, so this is one, if you consider this is 40 is the mean strength. So lowest few sample you will find will give you 25 also. Few sample you will find it will give you 30 MPa. Few sample will find you will give you 35 MPa, and maximum sample you will give you 40. Few will give you 45, 40. So that's what. So this is the histogram, right? Now in this concrete, which strength will you consider? Will you consider that the strength of concrete is 40, or the strength of concrete, the same grade of concrete is 45? Which one will you consider? If you consider 40, what will happen? Some sample will have 35, 30, 20 also. Some sample will give you less strength, some will give you more strength. So now if you construct a structure by considering 40 MPa, what will happen? So some portion of the structure, the strength is not 40, it is less than 40. So our structure is not safe in that area, whereas some portion it will be obviously overestimated, so this portion won't fail. Whereas if you consider 40, then 50% chance that material is less than the 40, strength of material is less than the 40. So now which value will you consider? So whatever code says, IS 456 Indian Standard Code specifies that you should take that value where only 5% defects are there. In any case, only 5% possibilities are there, then the structure strength is less than that value. That value you have to consider. If you consider 40, what will happen? 50% your times it will be less than 40, right? So we should not use 40. So code said you go to 5%, where 5 below, so below 5%, if the failure chances are below 5%, only that strength you have to take. So in this case, we'll take this strength of the concrete is 30. We won't take 40, we won't take 45, we won't take 50, we will take 30. How we got 5% area. Now this area is basically 5% area. So now if you use 30, then only 5% probability is there, then the structure strength is less than 30. Whereas 95% times the structure strength will be more than 30. So that's how, so this strength 30 is actually called characteristic strength of a concrete. And this definition is given in the IS 456. You can get it. So the strength below which not more than 5% of the test results are expected to fall, that strength we will consider. So see, we are always keep going into safer side. So although the maximum samples gives 40 strength, but we won't consider 40 in our design. We consider the strength of the concrete is 30. We are going below. We are underestimating the concrete to become in a safer side. So only 5% probability is there, then the structure strength is less than 30. So that's why 30 we will use as our strength. Whereas 95% chances are there, it is more than 30. So our structure will be safe and 95% time. So this 30 is actually called characteristic strength of a concrete. So very much important properties, and I think you have to understand very in details this what is the characteristic strength of a concrete. So just recall. So during this type of histogram we have drawn for the load case also. In the lecture 2 we have discussed about loads. In there also we have drawn this type of plots, and that name was characteristics load. So in case of loads, always we use this side. 95% times that load should not exceed that value. Whereas we are increasing the load. So our main objective is what? Our main objective is our structure should be safe. Our structure should not collapse in any condition. Right. So when we estimate the loads, we always estimate load over, or I mean we estimate overestimation of loads. Although load may be less, middle, mean, but we consider our load is acting here. More loads we are considering while designing. Whereas in the material properties, basically we are going backside. We are for making into safer side. We are going left side, and only we are considering 5% probability that material will fail. So this is two important things you have to remember. One is for the load purpose, we are increasing the load. from the mean value to become in a safer side. Whereas in the material properties, we are decreasing the material strength to again to become in a safer side. So this is very much important. Whenever we have the load, we multiply with some factor to get higher loads. For example, in a structure, load is acting 100 Newton. So while designing, we'll consider not 100 Newton, we'll consider 150 Newton is acting. So we increase 100 to 150. We design a structure where 150 Newton load is acting, although in reality the load is 100, right? But in design, we consider it is a 150, for example. Whereas the material strength, although the concrete gives maybe 30 MPa, the characteristic strength of the concrete may be 30 MPa, but for our design purpose, we won't consider even 30. We'll reduce it. We'll consider maybe 20 MPa. We consider that the strength of the concrete is 20 MPa and we design. So always we are in a safer side. In materials, we are decreasing our strength, whereas in a load, we are increasing our strength. So that's how is characteristic strength of a concrete. So now next property of concrete is flexural strength. Now what is flexural strength? So flexural strength is, so whenever we apply a load in this fashion, if you see this diagram, so this is the diagram. So we understood that in the last properties we saw characteristic strength. Characteristic strength is nothing but a compressive strength. Basically, we applied compressive force in a structure in a concrete cube, and we find it out the compressive strength. Now here we are calculating the flexural strength. What is flexural strength? Flexural strength is, it is, we are finding out the splitting tension strength of a concrete. So this is a concrete block, and we are keeping, these two supports are there. Here one support, and loads are applied. So these are two loads. So total maybe P load, half load is applied here, half load is applied here. So once the loads are applied, we saw in a structural analysis what will happen. The beam will bend. So how the beam will bend? So beam will buckle and it will bend something like that, right? So in the last course we saw how the loads, after applying the load, how the beams are bending. So this is the bending shape of a beam. So now if you see, okay, let me draw it three-dimensional. So this is the shape of a beam once the loads are applied, right? So this is the typical shape once the loads are applied. What will happen if you see what happens at the bottom fiber? So this portion. So at the beginning, this was the beam. This is a perfect rectangular shape. Now after you apply the load P1, P2 in two locations, the beam buckles. This is a buckling shape of it. This red color shape is buckling shape of a beam. So now after beam buckles, what will happen? At the bottom side, if you see, this portion is stretching. So the length, if you see, this portion is stretching, whereas the top fiber is basically compressing. See these two fiber coming nearby, right? Whereas this portion is actually stretching. So bottom fiber has length has increased in the bottom fiber, whereas top fiber the length is actually decreased. That's why the bottom fiber is having the tension force, it is stretching, whereas the top fiber you will find this is a compressive strength acting, it is a shrinking in nature, right? So because as I mentioned that concrete is very good in compressing strength, whereas concrete is very weak in the tension. If any tension force is acting on a concrete, the concrete will fail quickly. So this fiber, once we apply the load transversely, what will happen? The bottom fiber is under tension, whereas top fiber of a concrete is under compression. So concrete can take compression force, so top fiber there is no problem. Whereas in the bottom fiber, if you see, it is a tension force is acting, and concrete cannot take much tension force. So that tension force basically we are calculating how much concrete can take the tension force. That is the we call it flexural strength. So as per our Indian standard IS 456/2000, and if you go to clause number 6.2.2, in this clause, it is mentioned that the flexural strength of the concrete can be taken as FCR equal to 0.7 times root over of FCK. Okay, so what is root over of FCK? Root over of FCK is the characteristic strength of the concrete. Means if you are using M20 concrete, so this beam is made up using M20 grade of concrete, then then the FCK value, FCK is characteristic strength value, is basically 20. Now you can find it out what is FCR. So FCR is equal to 0.7 times root over of 20. So how much you will get it? So 0.7 into root over of 20, approximately you will get something like 4.5 or so. So 4.55 into zero point 0.7, which is nothing but again 3 or something. So 3 MPa. So now you can imagine that the concrete, the made up of M20 grade of steel, grade of concrete, M20 grade of concrete has a compressive strength of 20 Newton per mm square, whereas the flexural strength or the tension strength is hardly 3 MPa, very less. Whereas compressive strength is 20, but flexural strength is only 3. So this formula you will get it in the IS 456 2000, and these formulas are derived in an empirical nature, means many experiments are performed, this type of beams were made and many experiments were performed, and ultimately this formula has been derived. So these are the empirical formulas for flexural strength of concrete. Now next is elastic deformation of a concrete. So what is elastic deformation of a concrete? So once you perform the load deformation curve, I mean the compressive strength of a concrete, so this type of curve you will get it. So whenever stresses are increasing in a concrete block, the strain also increases, right? Strain is nothing but change in length by original length is the strain, and stress is force by area. So whenever you increase more strength on a concrete block, so the ultimately strain also increases. So this type of plot you will get it. So once you perform the compressive strength of a concrete. So the early tangent of this curve is actually nothing but the modulus of elasticity of a concrete. So this is another property, that is the modulus of elasticity of concrete, and how much what will be its value. So this is the value. So again IS 456, if you go clause number 6.2.3.1 in this clause, you will find this formula. So modulus of elasticity of concrete is EC, we call it, which is nothing but 5000 root over of FCK. What is FCK? FCK is the characteristic strength of a concrete. Now again, if you use M20 grade of concrete, so M20 grade of concrete means FCK value will be 20. So in that case you can compute what is EC. EC is 5000 root over FCK is 20. So which is nothing but 5000 into root over 20, something like 4.5 will come, right? So whatever you get, that is the modulus of elasticity of M20 grade of concrete, and this you will get it in this clause, or that value. Okay, so this is nothing but a modulus of elasticity. Modulus of elasticity means this the tangent in the stress strain curve. This modulus of elasticity. This tangent is nothing but this value, whatever you get it. And this formula is also again in the empirical in nature. Many experiments were performed in a lab, and ultimately these values were recorded. Next properties of concrete is shrinkage of concrete. Now, what is shrinkage? So shrinkage is nothing but the the when the concrete, as I mentioned, concrete is made up of what? Sand, cement, coarse aggregate, fine aggregate, and the water, right? These four materials basically used for construction of concrete. So so in the shrinkage of concrete, basically concrete is made up of sand, cement, aggregate, and water also, right? So when the cement is mixture is mixed, concrete mixture, and then it is poured into the form, the shattering part, and ultimately after 28 days, basically the concrete gets hardened. So the water, whatever water is there, water content is there, it will evaporate gradually, and it will make the concrete more strength. So you can see when over the passing of times, basically the water content is actually evaporating, and ultimately you will have the solid part of a concrete. So when the water content is basically evaporating, what will happen? So it will create the void in the concrete. And that's why we can see this type of micro cracks in our surface or concrete surface. So these cracks you will find in everywhere, in every almost in every concrete structures, and these are nothing but a shrinkage in the concrete. Means because the water content in a concrete is basically evaporated, and this type of voids are actually present. So this is called shrinkage, and that properties also we have to understand. So if a concrete gives more crack, then we should, we should improve the crack width. Crack width should not be more than some certain limiting values. So as per our Indian Standard Code IS 456 2000, they said if we don't have any shrinkage data, then we can consider the total shrinkage strain is 0.003, 0.0003 in absence of any data. If you don't perform any experiment in the lab, then we can consider the total shrinkage of a concrete is this value. and you will get this value in the clause number 6.2.4.1 in the S456. So now another very important property of concrete is the creep of concrete. So what is creep of concrete? So creep is basically the time dependent shrinkage, or time dependent deformation is nothing but a you know creep. So by which basically the if you know you can see that the deformation of a structure will gradually increase when the days passes, when the age of aggregate increases. Basically at the beginning, within 28 days or 1 year, you will find the deformation in a beam. So that is because of shrinkage. But after, when the days passing, the year, 10 year, 20 year, 50 year passing, you will find the deformation of a concrete is increasing. So that time dependent deformation, actually we call it creep of a concrete. So the value, so the if you can see, the modulus elasticity of concrete also will change because the deformation increases with the age of concrete. So this value, this is the formula to calculate the creep of concrete. Again, this value is given in the IS 456.6.2.5.1 clause number. You will find this formula. So these formulas are empirical in nature because many experiments were performed in real life, and then ultimately this type of equations are derived from the experimental results. So in details, we will study in the concrete technology course what is the creep of concrete. But here I'll just summarize what is creep. So creep is nothing but the time dependent deformation of concrete. So by which it will continue to deform. The concrete will continue to deform under the compressive stress. So that is nothing creep. And then the next property is the thermal expansion of a concrete. So you can see in many areas in India, when during the summertime, the temperature increases up to 45-50 degrees centigrade. So because of high temperature, or the concrete material tries to expand. So that also some values are given. So if different types of aggregate, and this is the coefficient of thermal expansion, that also has to be calculated while designing, because in a structure we have to keep proper distance or proper gap, because during the summertime the structure may expand because of thermal expansion, the entire concrete slab may expand a little bit. So we have to give proper space for the thermal expansion, so that there is no additional stress in a structure. So these thermal expansion values are these values we can directly consider with different types of aggregate, and this table also can be found in the IS 456, the 6.2.6 clause number. You will find this table. So while calculating, so if a structure is constructed in a Hyderabad or in this region, in then the summer time, what is the peak temperature corresponding to the how much expansion takes place? That expansion gap we should provide in a structure in Hyderabad. Whereas if you want to construct a structure in a Kashmir region, there may not be temperature expansion, may not be very much important. In that case, you may ignore that part as well. So depending on the areas, that the structural design will change. So all these things we'll see in later lectures. Now the last property of concrete is basically workability and durability of concrete. So concrete mixed proportion. Mixed proportion means concrete, we know there are the four ingredients are mixed and concrete are prepared. So in what proportion these four ingredients will be mixed, that will be given in this IS code. So once if you get IS 1026 to 2009, in this IS code you will find how to mix these four ingredients and to prepare the concrete for the construction. Similarly for the workability also. So we will get in this clause what is what should be the minimum workability of the structure. Similarly, durability of concrete, you will get clause number 8 IS 456. Similarly, design mix and nominal mix of the concrete you will get in this in this clause. Similarly, batching also you will find in this clause. So all this clause, if you read, you will find in details what is the each procedure. As per IS code only, we have to construct a structure in India. So this is the properties, and these are and with respect to, these are the clause numbers where in details all the procedures are written. So these are the properties of concrete which we have to understand in details while designing of a structure. So in the next class we'll discuss about the properties of steel. So in this class we have discussed there are 4 to 5 major properties of concrete. Thank you so much.